Welcome or welcome back, for those of you who have joined previous talks as well, to the 7th edition of Programmers Week. For those of you who have just joined, I just want to tell you that so far we've had great tech talks from Sydney, Manila, Bangalore, Romania, and the cloud track is still far from being over. We're continuing with a talk from Ukraine before crossing the ocean towards the Americas with talks from Argentina, Canada, and the US. Now, let me introduce you to Yurii Skolozdra, Senior Software Engineer. He enjoys teamwork, constant self-development, and the implementation of new technologies for improving the projects he works on. On the personal side, he likes music, namely vocal and guitar, and sports, football, boxing, gym, and table tennis. Yurii will talk today about Azure Container Registry. But before passing the mic to Yurii, I encourage you to share your questions in the chat module, and we'll address them at the end of the session. Yurii, you have the mic.
Thank you. Can you hear me properly?
Yep.
Okay, good. So let's start. As it was said, I'm a software engineer in a Cognizant Softvision company. I have been working directly Cognizant Softvision for 2 years. And today we are going to talk about Azure Container Registry. What is it? Why do we need it? And how to work with this. So first of all, let's begin with prerequisites. When we are talking about Azure at all, we need to know that it is like infrastructure, which allows us to deal with different services, to build almost all the features which in about 5 or maybe a little bit later, 7 years ago, we need to build almost from scratch. And for that reason, we had to deal with different types of applications, as well as different services like messaging systems, like mass transit or Rabbit or Kafka. But Azure, as a platform, it allows us different types of services to be managed by a person, and we don't need to involve a lot of people in that process. We have a lot of operational guys, this. In our case, we can call them like DevOps team. We have just people who is programmers, and they are all managing software engineering by their own in their specific places. But from our perspective, Azure allows us to do it all together, as well as messaging systems, application, app services, and etc. So for perspectives, we need to know, first of all, some simple thing like a Docker. Because Azure Container Registry, it currently works all of about Docker service, and this is also a platform. And I think everybody, maybe not everybody, but a lot of people know about Docker. And this is platform for building, running, and shipping applications. And this is a starting point for Azure Container Registry to play with. So what is Docker? It's simply, I have 3 maybe points around this. Yes, this is currently open platform, so we don't need any subscription, etc. To start playing with this, and it's allowing us to separate our infrastructure. So a long time ago, firstly, there weren't any containers, and we were playing like virtual machines, so we need to go ahead and start creating our server, and then on the server we need to ship and run our application, and that application depends on different type of frameworks, and in that case we are restricting us to the specific platform, etc. Maybe it, like common practice, it will be on the Windows machines or Linux systems, but it also as related to this, it impacts the cost value. And for instance, if we are talking about as it is related to .NET technologies from my side, as I'm mostly working with .NET technologies. So for instance, we are restricting ourselves to the platform, whether it can be different version of the framework. For instance, .NET 4.7 or etc. It doesn't matter the actual number, but it can impact on our virtual machines. And as a result, the concept of Docker was introduced, and it allows us to isolate and build our application in like isolated layer and ship it all together to different platforms. I can even send it to, for instance, my friend, and it doesn't matter which OS he has on his machine, but he can just run and execute our application. For that reason, Docker was introduced and became very popular. And currently, there is various another orchestration systems which can be grabbed and used, but specifically in our case, Azure containers are working with Docker, and it's building on the Docker Hub. So it's I know a lot of different comparison for Docker, but if you are talking about specifically, it's not only a container, as you can see this box, but it's almost like a microwave with it in it, because you are shipping almost the complete application to the end person. If it's rather your can be your friend, or if it's our Azure Container Registry. In that case, we have three main points. It's fast, consistent delivery. You have responsive deployment and scaling. Rather, it can be orchestration system like Kubernetes, which is built on Dockers, and you can run a lot of different apps on the same hardware, and we don't need to care about whether we are going to have any dependency on framework, etc. We can just deliver the app to the machine to start the server, and that's it. And basically, that's what allows us from Azure standpoint. So, as I said already, we can see on these graphs that we have VMs with containers, and as you can see on the VMs, as usual, we have guest OS, which I have mentioned, and on the containers itself, we just have all full together. So Docker allows us to have the app where we have our bin or library, and there can be installed different framework, rather it's .NET, Node.js, etc., and delivers to the end application. And we don't need to care about operating system, which really impacts continuous delivery. So let's talk more about what is Azure. So as I said, we have Docker. We can containerize our app and ship it somewhere, but where do we need to ship it? So in our case, it is container registry. Why Azure? Because Azure allows us different type of security, like Azure directory, and we can have different type of resource groups, and Microsoft currently takes responsibility for security of our containers, etc., or app services, and another types of application. We can through Active Directory make sure that our application will be handled correctly and it won't shut down in an appropriate way. And it's all about different type of pricing, but we are paying in that case for our security, for our autonomic, for our autonomicity, as I said, and that the app will be managed and we can rely on the Microsoft services in that case. So let's talk more about Azure Container. So we have this service allows us to store our images. So we containerized application in Docker image, and then we just need to ship into the Azure Container Registry service. And as I said, it is built on the Docker Hub Registry 2.0. Currently, they are developing in better way to maybe even swift to the Dockerized, and it's named like containerized app. But in this case, we will still explore it through the Docker container. So Azure Container Registry Service is just like a tooling where do we have like, it can be compared to the big car, which can handle a lot of different types of boxes, and it is delivered and stable and secured. What is more important that we don't need to think about how is this build, how is it going to be deployed. We don't need to think about any different type of triggers to automate the source code, because we can just grab our local image, Dockerize it into Docker image, push it to the Azure Container Registry, and there are a lot of different types of pushings, because Azure currently is very well developed, and it allows us not only push it from the local machine, from the GitHub, it's also allow us to push images from whatever links, URLs you would like through the Azure CLI, which is very progressive nowadays. And after that, after you have those images in the Azure Container Registry, you can push it to the web app containers. Rather, it can be Kubernetes services. It can be just simple app service in the Azure as well, and or it can be just container instance in the Azure as well. So I have already talked a little bit about this, but let's take a look at the different use cases. So main use cases, it can be pushing different type of application to the Kubernetes app service, Service Fabric and others. And it allows us to not worry about delivery process of our application, because it manage our containerized applications through different hosts, and we don't need to spend any time of delivering the our app, for instance, on the server. It allows us to spend much less time on managing and operating our, for instance, virtual machine. We don't need to go to the server, take a look what's happening, what's going on there, why it's down, if it's down, or why it's not currently working in in good way, for instance. As I said, Azure command line interface or even you can push it through Visual Studio Code, Azure account just in web, and we have, I think, around 4 types of allowing to push and pull images, and this is all about tasks, Azure Container Registry service tasks, and we just need to configure at this set on this slide and automatically rebuild application. So as a developer, I don't need to worry if it's being delivered or not. I just need to push an image, like push some changes in our, for instance, GitHub pull requests or etc. And continue with, as I said, this is the main image for that reason. I have just Visual Studio. I containerize my app, push to GitHub. GitHub, we have Azure wrappers. We configured Azure pipelines, and on the Azure Container Registry, we have our instance of app. So if we are doing any other changes to our application, we just rebuild the image and push it to the Container Registry. And Container Registry can be also configured, and on the latest changes, it can redeploy the application, for instance, to the Azure Web App containers. And in that Web App containers, we will have new live and running application after it is pushed to the Container Registry. We can do it on demand. Don't know, really doesn't matter if it's configured from our side. If it's configured just on the Azure pipeline or we can, for instance, create some tasks on schedule purpose, and which is going to push and pull the images. So in a more deeper picture, for instance, we have Azure Kubernetes services. As you can see here on the left, we have Azure pipelines, where we are registering our app. We have Docker push. We can push just to the Container Registry service, and Kubernetes cluster can be configured based on our different images. And after that, it's just all about having all together all services playing with each other. So for instance, we have different type of utility services. We have backend, and on the Azure Container Registry, we can push a lot of Dockerized applications, and altogether they can be configured to be published to different type of services, like just backend services, or maybe it's utilities, or maybe we can divide our front end from that, and based on our configurations, we can just rebase our different source of codes and just push there and be managed by a Container Registry. So let's go. If we are talking about key features here, so we have registry server tiers, which is more about pricing. So it is on demand. We have basic, standard, and premium, and all of them are working with Azure Active Directory, and each supports webhook integrations. This is the main key point. Security and access, as I said, it's also being handled by Azure, by Microsoft, and we know that we have HTTPS and TLC connections to secure our clients, and also we have a lot of different type of images and artifacts supported. Currently, actually, it's more working about Azure. They are developing the containerized version of the Docker. And as I also mentioned about tasks, that we are allowed to do automated image builds. Image builds just simply, as I already described, streaming the images to the Azure, deploy them, and extend our development process without caring about how and when it is going to be deployed, and to how to work with that. So let's talk about pricing. As I mentioned, those tiers, we have basic, standard, and premium. So it's more about storage for our Dockerized apps. So basic, it's pretty common. It includes us 10 gigabytes of storage on the Azure Container Registry, and have total webhooks as 2, and don't have geo replication. Let's talk about geo replication a little bit more. So in a premium case, we have geo replication. It means that we make sure that, for instance, if we have bad weather in some kind of region, we won't worry that maybe our server, because it is cloud technology, but it also is hosted through different servers, and we make sure in that case, if we're just getting the premium point of view, we can imagine that we, for instance, have one server in Romania, another one in, for instance, UK, USA, and we don't care if maybe somewhere of that place can be like bad weather or something is going wrong with servers. We know for sure that our containers won't shut down, and it will offers us more autonomic workflow. And as well as Premium offers us pools called multiple concurrent nodes, which allows us to not worry about managing through them as well. Let's go further. I would like to more specify on the demo of that, how to create, how to pull, how to work with the images based on the very straightforward example. So our goal will be create our own Azure Container Registry, push the application as a Docker images. So for that, I have prepared 5 steps. It will be create Azure Container Registry, prepare test application, create the Docker file from scratch, create the image based on the Docker file, push the Docker image to our Azure Container Registry. So let's navigate. So as you can see, it's pretty simple. If you are going to the Azure portal, we can navigate to the container registry and just click on create. And it is pretty straightforward. Is if I go on Microsoft Azure to the portal, we have different type of services. And as you can see, pretty straightforward. You just navigate here and can play with different type of images. Let me do the following. So we have container registry. I can just go ahead and create based on demand. In that case, I'm just starting the first step of my flow and creating the application. So as you can see here, we need to have some type of subscription. In my case, it will be Visual Studio subscription, and based on demand, you can grab whatever you would like. And also we need to create a resource group. Resource group is sometimes of grouping all together our services. In the resource group, we can have different types of services, like containers, we can have apps, we can maybe Azure functions, or whatsoever. And it allows us to just managing the access to that, to our resource group, and divide and like participate with another people, maybe on your team or across multiple teams whatsoever. Just simple as it is. So we have here not a lot of details. Basically, it's the registry name, in location. In my case, I have selected East USA, and I have selected also the SKU. So this is service tier as standard, and because I don't need any Go replication, and I don't need also more advanced feature like concurrent publishing to the different nodes. And after that, I can also customize networking encryption. In my case, I do need to do it, but if you would like, you can also configure encryption to the container registry, as well as adding a different type of tags. But in this case, just simple as usual. We are just creating, and after passing the validation, which takes up to 30 seconds, we can see all the basic information about our containers. After that, we can navigate back and see, as I described here, the login server to the our container registry. And in this server, we can log in from our local machine. We can log in from Azure CLI in web and push our images. Let me navigate back. So as you can see, we can just, as simple as it is possible, create maybe simple application like Hello World. In my case, it's .NET 5.0. I just for that reason, you just need to open VS Code, open terminal, run .NET new console, build the application, and after successful build, we need to create a Docker. So to create the Docker image, so first of all, you need to just install the Docker on your local machine. It takes about 2 minutes. I think it's not a problem. And as well as to build it from scratch, this is more testing application. In my case, it's running on the web, and it allows us to check how much CPU. It's more about having CPU more testing the performance of the CPU of the machine. In my case, I'm creating the Docker file. So first 2 lines, as you can see here, it is saying what SDK we would need to have our Docker image, have our application running. In my case, in this, I selected 3.0 .NET SDK, so it's .NET Core. And to compare with, it can be rather, for instance, Python, Node.js, whatsoever. And it will be our build environment. So each application to be built, we need to have some framework. So locally, we have in Visual Studio prepared and installed, for instance, .NET Core framework, and it is installed on our machine. But as I said, we have this microwave altogether. We are shipping the already completed application to our server, to our container registry. In this case, we would need to have some type of framework which is going to build our app. So in my case, it's .NET Core. And as you can see, line 4, 5, we are setting our core project. In my case, will be Sharp Proj, as it is .NET Framework. And also, we are copying it to our folder. I just selected app as a work directory on line 2nd. And then on the end, which is also important, I'm setting the entry point of my application. In case of .NET, we are always dealing with DLLs, and our app, when it is built, .NET is running the DLLs based on the build application. And in my case, my starting point will be this performance testing of DLL. And basically, that's a pretty easy configuration of Docker file. As well as also would like to mention that for different types of like object and bin folder, which we are not needed, we can just create Docker ignore, and it will be automatically ignored by Docker. After successful creation, and after that, we just running Docker build on our local machine, and our application will just go ahead and be built on the server. After creation the app, we can go ahead and run, as I said, to check on the machine our image on disk. For instance, if I just check on my machine, I can see a little different images here, and verify that it's built and successfully containerized. In my case, my application. After that, we need to log into Azure. So here, important point which can be missed is the accessed keys. In my case, I just select the admin user and generate the password. Those passwords can be regenerated, or admin user can be also disabled, and we can manage the login to the our containers through the Azure directory. But I have just selected admin user and put the password, generate the temporary passwords, and after that I log in from my local machine to the Docker, where I put my login server and password in this case, and then after successful logged in into application, I can push the image create tag, which is pretty, we can skip this, but in my case it will be better to just have simple reading tag. I just selected the name of the application as well as my server, and pushed it to the Azure Container Registry. On the image below, we can see that my app was successfully pushed, and this is described. This is describing the simplest flow of pushing the latest image of our application from the local machine. It can be, as I mentioned in the beginning of meetup, that it can be configured so the tasks, and after having app created, maybe pushed to the some kind of repo like GitHub, TFS, whatsoever, and after that we can simply create the tasks on the pipeline to set our pipeline to manage the pushing of latest image of source code to the Azure Container Registry. For instance, on GitHub, we can have like just source code. Then after that, we can create and manage to have it containerized by Docker and pushed to the Azure Container Registry. And we don't need to worry about a different type of shipping process. So in some case, we need to make sure that, for instance, virtual machines that we have that kind of Docker framework installed. We need to re-update it this framework on the server. If it's because the server is basically like our local machine, but we just log into that and verify if it's working or not, what can be wrong with that. And in our case, we don't need to worry about that. And after having the container registry pushed already, we can, as simple as it is possible, create just instance of that. So in my case, I just create the instance of my application. And after that, we can also select based on what image I'm going to create this, and it will run on the, in my case, I selected the Linux OS type, and it just going to run my image on the Azure based on my container. So image source, I have selected Azure Container Registry, and just for testing purpose, I can after that verify that my app is running on the Azure site and it's working fine. And as you can see here, it's an instance of container. It's just, I would say, the simplest way to run the app on Azure. In common practice, it will be app service, where we all can configure a domain, etc., and also the access, and pushing and running the images in app service will be also the similar solution. In my case, I just created a container instance based on my container, and I have IP address for that, as you can see on the right. And through that IP address, I can navigate to the application and make sure it's running and up. So in my case, I can just go ahead and see that my app is running. I can select some type of loads on the app server, and then go ahead and test that I'm pushing something, that my app is still running, how much CPU memory and networks it is used now currently, and everything is configured for from this view on web. And I don't need to worry anything about how it was run, what else do I need to do. So we are skipping a lot of steps, which is common in our nowadays development. That all allows us through the Azure infrastructure. To summarize, we can just simply think about this as I said, a big track, so like car or track. So Azure Container Registry enables us to grab and make sure our containerized app exists. We can easily access to them. We can create instance of them, deploy or redeploy, push images to that container registry, or up and run. And important thing, it's always about security, that Azure is allowing us to secure our containers based on the Active Directory, or just like I have selected admin user, and etc. And after successful deployment, we can store our images in one place and do whatever we want. Rather, it will be web apps, just simple web apps from simple application, or it can be Kubernetes services, and we can also push some type of workers, buses, messaging systems, and don't care about it is, and rely just only on the Microsoft Azure infrastructure. And basically, I think that's all from my standpoint. So I think in that case, I can finish with the presentation in time. So thank you all for listening for me. If you have any questions, please ask us.
Thank you, Yurii. Really interesting. Let's see if anyone has any questions. No questions so far, Yurii, but I'll read them over if they come.
Okay.
Okay, seems there are no questions. So Yurii, that means you've explained everything really awesome. Thanks again, Yurii, for this presentation. Thank you everyone for joining us in this Tech Talk. Remember that there are still Tech Talks remaining for the rest of the day in the cloud area. Like I've said before, we're crossing the ocean towards the Americas, where we'll have really interesting Tech Talks as well. So stay tuned and have a really awesome day.
Thank you, guys.